Hey everyone, and welcome back. I'm thrilled you're here. Today, we're getting into a really fascinating explainer. We're going to unpack a wonderfully detailed developer diary entry by a programmer named Aang. We're specifically looking at their notes on Haskell programming, part 205 to be exact, where Aang logs the journey of fixing a seemingly harmless bug in a tool called X2 to eBook, which is used to generate ebooks from text files. We're going to see exactly how a tiny, well-intentioned tweak led to a completely bizarre display issue, and what that actually teaches us about the foundational quirks of the languages we use every single day.
So, question for you. Have you ever tried to fix a tiny, almost insignificant piece of code, only to accidentally create a much uglier bug in the process? You know the feeling. It's the classic developer trap. You go in with the best intentions to clean things up, make the code base just a little bit neater, and suddenly you're staring at a total mess on your screen. That is exactly the situation Aang found themselves in, and it's a journey that perfectly captures the hidden complexities of everyday programming.
All right, let's look at Section 1, the code duplication problem, keeping it clean. Like every good bug hunt, this one started with a simple desire to just keep things clean. Aang was in the middle of updating this ebook generator, adding a new argument so users could set a publisher name. But when Aang looked at the recommended code, there was a glaring issue. They had to hard-code the publisher's name twice. They needed it once for the actual default value when a user doesn't provide a publisher, and then they needed it a second time just to display that default value in the help text. Now, the default publisher name here was a specific set of Chinese characters, Zhiryu Wenko. And as any developer will tell you, repeating a hard-coded value is just a recipe for future errors. It totally violates the DRY principle. Don't repeat yourself. So Aang decided to fix it.
Which brings us to Section 2, the escaped Unicode trap. A built-in betrayal.
And here is where the story takes a twist. To get rid of that annoying duplication, Aang swapped the code to use a built-in helper function called showDefault. The goal was super simple. Just pull the default value dynamically so it doesn't have to be typed out twice. But when Aang actually tested the help message, instead of seeing those beautiful intended Chinese characters for the publisher name, the terminal spit out an absolute mess. It was an escaped numeric string, \25351, and so on. The raw output was completely gone, literally replaced by something entirely unreadable to a standard user who's just looking for some help text. So what exactly went wrong here? Well, let's look at the root cause. The culprit was actually that handy showDefault function. See, it doesn't just pass the text through as is, it actively inspects the default value using its show instance. And in this programming environment, relying on that show instance meant those raw Chinese characters were automatically converted into their escaped numeric values for display. Aang tried to take a totally reasonable shortcut, and the tool's underlying mechanics basically set off an ugly Unicode escaping trap right in the user-facing help text. Let's move on to Section 3, the shared constant solution, an elegant fix. Clearly, that hacky shortcut was a bust. So, instead of relying on a finicky built-in display function, Aang took a step back and solved the duplication manually through some really solid architectural practices. Step 1. Aang defined a completely new shared constant called default publisher. Step 2. Aang updated the export and import statements in the codebase, pulling this new constant into the necessary files. And finally, Step 3. Aang applied this shared constant straight to the args model, totally stripping out that hard-coded string literal. By creating a single source of truth, Aang squashed both the code duplication and the display bug simultaneously. Now, there's a really crucial detail here that we shouldn't overlook. When setting up that new default publisher constant, Aang made a very deliberate choice. They used text instead of string. And why is that? Because the model type over in args.publisher was already defined as text. By making sure these types matched perfectly, Aang guaranteed complete consistency across the application. It's a subtle move for sure, but it's the absolute hallmark of careful programming. You aren't just slapping a band-aid on a bug, you're making sure the fix aligns seamlessly with your existing data models. And that opens up a much bigger conversation in Section 4, the string versus text debate, a foundational quirk. Let's zoom out for a second, because this one tiny bug actually highlights a massive foundational quirk in the Haskell language itself. To really get Aang's final takeaway, we have to look at the landscape. In Haskell, there is this legacy standard where a string is essentially defined as a list of characters, shown right here as char. It is the older default way of handling text. But then, on the flip side, we have text, which is the modern standard, the exact one Aang purposefully chose for the publisher model. The friction between these two types, the aging defaults versus the modern necessity, is at the core of so many quirks developers face in this ecosystem. Which leads us exactly into Eng's commentary on the broader state of the technology. Eng points out a really hard truth here. There absolutely needs to be a concerted effort to modernize GHC's core libraries. The community has got to move away from that legacy string default and fully embrace text as the standard. But, honestly, Eng is also wonderfully realistic, maybe even a little cynical about it. Judging by how notoriously slow the Haskell stack progresses, Eng seriously doubts we're going to see these core defaults change in the coming years. And it's a super relatable frustration. The tools we use are built on foundations that age, and trying to turn a massive foundational ship like that takes forever. And that wraps up our explainer for today, leaving us with a pretty provocative question to ponder. We've seen how one old default in Haskell caused a cascading formatting issue for Eng. So I have to ask you, what legacy defaults are slowing down your stack? What foundational quirks in the tools you use every single day are secretly piling up technical debt or forcing you to write awkward workarounds? It is definitely a great question to keep in the back of your mind the next time you sit down to refactor a piece of code. Thank you so much for hanging out with me to explore Eng's notes today. Keep learning, keep questioning your defaults, and I'll catch you in the next explainer.